Hi, welcome back. So we're in chapter 4, World of Prediction. In this chapter, we're going to be looking at number of outlines. First of all, we're going to start with introduction to prediction, and then map of prediction, and then we're going to look at the map from both sides, right and left, and from the source. Let's go ahead and explore the essential introduction. Well, in general, the academic definition of prediction has to happen that to assume something about the future. How to do that with relation to the matter of accuracy? Well, if you want to actually get to the point of making a prediction about something might likely to happen in the future, it can be a huge responsibility, first of all, to establish a framework, some certain requirements before you reach to the stage where you can say that I am doing prediction. Because prediction is beyond just only using specific algorithm or technique or tool. It's as a strategy. It's a sort of ideology in the way that people have to think about the future. And if you do that, I think the accuracy will be accomplished. Next, we're going to be looking at the map of prediction that we'd like to introduce to this course. Honestly speaking, it took me a very long time to actually create this map and try to bring every aspect or piece of information that you really have to understand in order to comprehend the idea of prediction. This map is divided into the right-hand side of the map, which is going to cover this area here, and the left-hand side of the map, which is going to cover this area here, and of course the source of the map, which is starting, not surprisingly, to be the data, and all of which is going to be at the heart of artificial intelligence framework, plus some of the tools, the most popular tools and frameworks that you can utilize them in order to execute every single detail inside this map. So actually, let's go ahead and elaborate the first part of the map from the left-hand side, this particular area. Now, most of the people in many courses, guidelines, unfortunately, usually speak about the data when they want to link to a prediction, as if you have data, jump to the right-hand side by doing the predictive model. And this is a very, very wrong mechanism, I could say, to reach to a good prediction. So basically, once you have your data established, the first thing you need to move to is to make something called a descriptive model. It means to understand what is your data is all about. It means to actually form and articulate the right research question to find out what is the space of variable you would like to do, what are the features, how they are correlated to each other, etc. All of which can be actually inside two important work frame, if you will. First of all, data analysis, and then mining the data. This will give you the actual descriptive model anyway. Now, all of which actually I have already explained in much details in the previous book. So if you are interested, of course, to find out much more details, you might want to check the previous book analysis from the start to the end to understand all the detailed steps to create such a descriptive model. Now, once you have done the descriptive model and you create the analysis correctly and you made the mining for the data correctly, then this descriptive model is ready to be fed into the box of predictive model. Now, next, we're going to look at the right-hand side of this map. So now we are actually at the core purpose of this book, and that is prediction from the start to the end, where we're going to have guideline or the path of creating prediction correctly based on the side of the map. So once we have received the descriptive model, we are ready now to do prediction. But there is an important question to ask based on, of course, the research question or based on the type of the model of the data that we have. The question is the data that I have at hand labeled or unlabeled? The question is, what do we mean with labeled and unlabeled? Now, if you would have like such a table of 4 different variables, well, that goes back to the research question. Let's assume if I am interested actually to predict the actual value of x4, given that x1, x2, and x3 is known. In this case, we call this kind of data, it is labeled data. Why? Because I know exactly the target, what exactly I would like to predict. Now, from mathematical perspective, as we explored in the previous chapter, write x4 as a function, actually. This is the meaning of a labeled data. Now, from academic perspective, called a supervised kind of learning. Now, the second question you're going to ask yourself, is this label, the x4, is it a continuous kind of label or a discrete? If it is a continuous kind of a value, well, there are 2 possible paths you might take. Depends again on the research question. The first one is to consider the problem as a regression problem. The second one is to consider the problem as a probability problem. And both of them are completely different. So if it is a regression problem, then we can go and decide on X4 or in the entire space of the problem to be linear, non-linear, or maybe multi-linear. It doesn't really matter. All the possible algorithms then can fit inside here. If your problem is a probability problem, this is where you're going to look at a kind of a distribution. And in particular, since it is a continuous, it's a kind of a density distribution problem. How about if the label is a discrete kind of label? Well, once again, you're going to look at the problem from two different perspectives. The first one, we call it a classification problem, since it is a discrete. Otherwise, it's a probability problem. If it's a classification, well, this is where you have different algorithms are available, such as decision tree, or maybe naive bias, or logistic regression, or even the neural network, or the deep learning in principle, actually. Otherwise, it's a probability direction. This is where we're going to look at the distribution. This kind of distribution, we call it a mass distribution because it's a discrete. Now, this is the meaning of a labeled data or a supervised. How about if it is unlabeled? Well, we'll get back to the exact same example here with the same data set, but this time, task was not precisely to predict what one of these variables would look like in the future, but was given and to ask you to extract a pattern to understand the behavior. Well, I could look at this matrix from the column wise, from the row wise, and this is where we call this kind of problem unlabeled, because there is no specific things to predict in here. And unlabeled usually call unsupervised kind of learning. And this kind of a problem is centered around the idea of a clustering problem. And now based on that, you can look at different kind of algorithms, such as the k-means, the hierarchical, or the centroid point algorithm, etc. But the point is to understand that the basic idea starts from what exactly your research question is all about, what kind of data you have. All these important things have been already established based on the descriptive model. Execution of those algorithms, those kind of a framework that I have, just picked some of them there, that can help you actually to make the execution of those algorithms quite a bit easier. Now, last, we're going to look at the source of the map. The starting point was based on the data. So the basic idea, if I don't have data, I think this entire map can't happen in the first place. Now, unfortunately, in many cases, that such data might not exist. For example, let's say earthquake kind of data. This is a recent project I was working on. Now, the problem is we don't have like a kind of a solid continuous base data that you can like take and rely on. It is not like a shopping behavior experience of a customer. So in this case, what we shall do and how can we go around that? And this is another entire actually basic field of a study, is to generate kind of a synthetic data, so to speak. The point is actually what kind of good data that you can generate and how to generate such data. It's not the focus of this course, but I would like to tell you that random is a very important principle when it comes to generate such data, because it turns out the behavior of randomness around us from the nature, it causes the action that we see around us. So I just wanted to say in this particular section that the focus on generating such data, or the study on this field, it's a very promising field, and I think we need it in many different kind of application, really. And the point is, once you generate such data, and then you can go down to the map as it is, create from that a descriptive model, then a predictive model. So that was the end of chapter 4. Now we are ready to start with the prediction application using the probability box, and that's exactly what we're going to explore in chapter 5. I will see you then.